Hey everyone, in this short video I just want to explain to you the effect of alpha, which is the significance level on the width of a confidence interval. In the confidence interval formula, you'll often see something like Z alpha divided by 2. That's also called the critical value. And that's just where on the Z distribution you fall. So for example, in the Desmos, you see a Z distribution, it's centered around 0, standard deviation of 1. And the critical value is just the numbers. In this case, it's 2.58 and negative 2.58 when alpha is 1%. So that means that your interval covers 99% of the probability distribution. The area under the curve in blue is 99%. So that means that the combined area in the tails, the white areas on each side, they combine for only 1%, and they're each 0.5%, right? And the typical width is 95%. That's the kind of the standard default is a 95% confidence interval. And you see that as we increase alpha, our interval gets narrower and narrower. So basically, if you want to have more error, again, alpha is the error rate. If you want a bigger risk of error, then you take a narrower confidence interval. The analogy I like to give is that, let's say you're trying to catch a butterfly. Do you use a wide net or a narrow net? If you want more risk, then you use a narrow net. You'll miss the butterfly more often. But if you want to be more conservative, so you want to be 99% confident, then you use a bigger net. You can also think of it as fishermen's. They use massive nets to catch fish, but some of them just use a small net to catch one specific fish, right? So as you move around the alpha value in this calculator, I'll put the link below, you get an idea of the effects it has on the width of the confidence interval. So keep in mind this has nothing to do with sample size nor with standard deviation. And because standard deviation is in the numerator, it increases the width because it's proportional to the error, right? Standard deviation increases the margin of error, and sample size is usually in the denominator, which means it's inversely proportional and it shrinks the error, which shrinks the width of the confidence interval. So I encourage you to play around with this, and in general, just see how Desmos is powerful with statistics. I'll link to an article that's quite useful on that as well. Thanks for commenting your question, and I'll see you in the next video.